Today we're looking at 15b, which is about the locus of points. So a locus is simply a path of a moving point or points that follow a certain rule. An example of a locus. We could have a rule that looks like the following. The locus of points given by pxy, so that's our group of moving points, needs to be equidistant or equal distance from 2 points R and Q. If we take a look at the diagram on the right hand side, we can see all these little dots through the center forming a line. This is my point pxy that is moving in the direction such that if it follows this line, the point will be equal in distance from R and from Q. So the distance PR and the distance PQ will be equal no matter where that point moves along the line. What does it mean we have to do? We have to form an equation of the worded rule and write the equation in an appropriate form, such as in the form of a line, circle, parabola, etc. First example, we have 2. A point pxy moves such that it is always 3 units away from the point C, where C has coordinates 2, 1. Find the equation of its locus. The first thing we have to do is rewrite this rule using mathematical notation. Now I like to write it out in simple words first, then underneath that write the mathematical notation. So what this rule is really saying is that we have a distance of a moving point, pxy, and the distance of this point pxy to the point C is always equal to 3. Now I use maths to express this. The distance of pxy to C, well, that can be given by my distance formula, the square root of x1 minus x2, or x minus 2 squared, plus y1 minus y2, or y minus 1 squared, and that's always equal to 3. So I can write that as equal 3. The second thing we need to do is to write this equation in a form that we think resembles the shape of the graph. So whether that's a circle, parabola, line, ellipse, hyperbola, etc. So what I like to do now is just draw a little diagram of what I think is going on, and that will inform me of how to rearrange the equation that I have developed. So I have this point C, and I have a point moving around it such that the distance from C to the point is always 3. It looks like my point pxy is actually going to move in a circle around C, just like the circumference where the radius is always 3. So I know what the equation of a circle looks like. So let's try and make our equation that we got into an equation that resembles a circle. First step is to square both sides. This way I get rid of the square root sign on the left, and I'm just left with x minus 2 squared plus y minus 1 squared. On the other side, 3 squared is 9, and indeed this is a circle with center 2, 1, and with radius the square root of 9, which is 3. Let's move on to something more tricky. Part 2. Find the locus of points pxy that are equidistant from Q, 0.02, and from R, -1, 0. Like usual, the first step is to write this rule in mathematical notation. So I know that the distance of pxy from Q, 0, 2, has to be equal to the distance of pxy from R minus 1, 0. That is what is meant by equidistant. Now let's express this mathematically. Distance pxy from Q02, again I just use my distance formula, so x minus the other x, 0 squared, plus y minus 2 squared. Take the square root, that is equal to, now I have the distance of pxy from R minus 1, 0. So this distance formula, again, the square root of x plus 1 squared plus y minus 0 squared. I'm going to tidy it up just a little bit, get rid of the zeros where I can. And now let's think. Do I think this locus is going to be a circle or something different this time? I think this is the path that my particle is going to travel along, a straight line directly between these 2 points. Okay, so now I have to rearrange the formula that I have into the equation of a line. Like we did in the last example, first I'm going to square both sides. If I square the left-hand side and I square the right-hand side, I just really remove the square root signs. Then I'm going to rearrange and try and get y on one side by itself. So let's expand the brackets. I'll get x squared plus y squared minus 4y plus 4 from the y minus 2 squared is equal to, I expand that x plus 1 squared, I'll get x squared plus 2x plus 1 plus the y squared hanging off the end. And notice I'll cancel. So the x squares will cancel, the y squares will cancel, and I'll be left with minus 4y plus 4 is equal to 2x plus 1. Take the 4 to the other side, I'll get minus 4y is equal to 2x minus 3. And then lastly, divide by negative 4. We will have y equals, well, 2 divided by negative 4 will just be negative a half x plus 3 on 4. So that's the equation of my locus of points. Part B, show that this locus or this path is a perpendicular, that means right angle bisector. So it cuts in half the line segment QR. We know that the locus is given by y equals minus x on 2 plus 3 on 4 from the previous part of the problem. The first thing we have to prove is that this locus or my line y equals minus x on 2 plus 3 on 4 is perpendicular to the line segment QR. In order to prove that two lines meet at right angles, the easiest way to do this is to show that the gradient QR is the negative reciprocal of the gradient of my locus y equals minus x on 2 plus 3 on 4. And by negative reciprocal, I just mean if you times the two gradients together, you'll end up with negative 1. Let's find the gradient of QR. So we've got to remember the gradient formula here. The gradient formula for QR would just be y2 minus y1 over x2 minus x1. I'm going to make the point R be x1, y1, and the point Q be x2, y2. Then I will have for my formula 2 minus 0 all over 0 minus 1. That will become a plus 1. So I have 2 over 1. That equals 2. That's my gradient of QR. Now my gradient of y equals minus x on 2 plus 3/4 is a little bit easier to find. That will just be the constant in front of the x, or minus a half. I multiply these two gradients together, 2 times minus a half, and I do indeed get -1. So I can conclude that these lines do meet at 90 degrees and are perpendicular. Next part of the question. This time I have to show that the locus or the path bisects the line segment QR. If it cuts the line RQ in half, then the midpoint of RQ should lie on my locus. Let's start by finding the midpoint of QR or RQ. So remember, the midpoint is given by x1 plus x2 over 2. That will be my x-coordinate of the midpoint, and my y-coordinate will be y1 plus y2 all over 2. I'm going to let R be x1, y1, and Q be x2, y2. So I'll get -1 plus 0 over 2 for my x-coordinate, and then 0 plus 2 all over 2 for my y-coordinate. Again, simplify it, we'll get -1/2, 1. So this is the midpoint of RQ. Now, we've got to check that it lies on the line. So does -1/2, 1 satisfy y equals minus x on 2 plus 3/4? What I'm going to do is I'm going to substitute the x value into my line, and hopefully we get y equals 1 when we do this. If we get y equals 1, then that point lies on the line. All right, let's sub it in. -1/2 just becomes a +1/2. Divide that by 2, we get 1/4 plus 3/4. That gives me y equals 1, which is what I wanted to show. So we can conclude that 1/2 lies on the line of my locus, and therefore the locus cuts in half QR. This is part of 15B.